Am audible?
Yes, sir, audible.
Okay. Okay. So last lecture, I think we have completed the unit number one, that is fluid statics. Okay. And today we are going to start our unit number two, that is fluid kinematics, or we say kinematics of flow. So after giving the assignment, some students, two to three students, uh, asked me about the doubts of some numericals. But here these numericals are there asked on the total pressure and center of pressure. Some of the students asked that one roller gate numerical. That numerical is belonging to the forces, total pressure and center of pressure on curved surfaces. So curved surfaces are not now in present syllabus. Curved surfaces are not there. Therefore, some of the numericals are we can say that what are given in the assignment are not related to us. So after this lecture, I will tell which numericals are not related, or revised assignment I will put on our group. So we'll start now fluid kinematics. Is it okay? Some of the students, I think two students asked me, one roller gate and one student asked me about two to three numerical. He is having doubt. So, or next lecture I am going to take in afternoon. So in that lecture we will cover some of the doubts of fluid statics. Still, we'll start unit number two. Okay. Unit number two is fluid kinematics. Okay. Now, what is meant by kinematics? Who will tell? Fluid kinematics. Fluid kinematics. Anybody? Anybody of you fluid kinematics? Define fluid kinematics. Anybody of you? Nobody. So before we will go to definition. So fluid kinematics is we know that it is a branch of fluid mechanics which deals with the study of the motion of the fluid, where forces are not considered. Okay. So the cause for any kind of motion is force, and in fluid kinematics, we are not going to consider the forces which are responsible for the motion. So only we are going to discuss the motion parameters in this particular chapter. So which are the motion parameters? First is there it is velocity, and second is acceleration. So other than that, we are not going to discuss much more in this particular chapter. So it is generally a continuous function of space in space and time. So we know that velocity, accelerations, when we calculate, these are the always function of space and time. So fluid kinematics also obviously it is a function of space and time. Okay. So this is a generally we are studying the motion. Motion means what? This is one motion. We can see the waves of sea. Okay, they are coming. Okay, and or water is going to be roaring in this particular sea. So this is going to be motion of the fluid particle, water particles in the sea. We are going to study. Before that, here also, if we are going on, we are cycling. If any vehicle we are going in vehicle in air is going to consider air is going to act resistance on us, so wind is also going to be flowing, so that motion also we are going to see. So here is example, by understanding this particular chapter also we can know which position is going to be best for cycling or to have the less resistance of air. So how the air is going to be flowing around this particular body. So all these things in detail, not now as is, yeah, these are the applications of fluid kinematics. So we can draw the graphical lines that is with that it's called as streamlines. Okay, around this particular cyclist, and here intention is there that so to have this less resistance, what should be the his position. So on this, if it is a perpendicular, definitely more resistance will be there. In this position, he is having getting less resistance of air, and therefore, a cyclist, more sports cyclist, where race is there, cycling race, definitely more cyclists are going to be bent. They are going to making themselves bend, and they are going to drive the cycle, because in this position, very less resistance is offered to this particular body. Okay, so this way, this chapter is going to help us. Okay, now here, to describe the methods of fluid flow, then there are two types of methods are there. Okay, so one is Langrangian method, and another is what here, Eulerian method or Eulerian method. Eulerian method, and one is what, Langrangian method. So what happens in the Langrangian method? In the Langrangian method is, if the fluid flow is consisting of many particles. So if you take a fluid, it is consisting of larger number of particles, if you atoms. Okay, so Lagrangian method and Eulerian method are the two methods for the for describing the fluid flow parameters. So which parameters we are interested? Generally in this chapter, we are interested in velocity and acceleration of the fluid particle. Then others are there, pressure, density. So these flow parameters. Somebody is unmuted, and we are getting little bit disturbance. So I think SY 454, Rakesh, SY 54, roll number 54. Please unmute. Okay. So there are two methods for describing any kind of fluid flow. One is Lagrangian method, and another is what, Eulerian method. So first of all, consider that these two methods. So what is happens in this is Lagrangian method, and one is what, Eulerian method. So to describe the flow parameters of fluid flow, it may be velocity, acceleration, density, pressure. Now in describe, what we'll do. So in Lagrangian method, what is done is that fluid particles, we have to trace the fluid particle motion, and we have to design the fluid flow parameters. So here, so fluid flow parameter means what? Let us describing the defined mass, position of velocity, acceleration, pressure, temperature as a function of time. So what we are going to do in this Lagrangian method is that we have to trace the motion of the fluid particle. Okay, how the fluid particle is going into that particular fluid flow, so we have to track or trace the motion of that fluid particle. For example, let us consider to track the location of a migrating bird. So those fluid birds are migrating, and therefore we have to be there. We have to track the bird. How the bird is going, with which velocity, whether it is going to be changing acceleration, how much pressure is acting on that particular bird. So tracking is important. So if we are observing the bird motion, so in that case, we have to also move with that particular bird. So here, observer also, what is that here? If we say in that observer, so when we have to observe the motion of that particular bird, so observer also have to move with that particular fluid flow. So observer is also moving. Okay, and we have to trace the motion of each and every. So it is one example. Bird is there. If the group of birds are there, so every bird motion we have to track, and in that case, observer is moving. So any observer is there. You can we also will be an observer. So I have to consider that observer also have to move, because how the bird is tracing moving, with that observer also have to move. And if the group of birds are there, definitely each and every bird we have to observe. So there are different equations for different fluid flow particle. Okay, and that is called as what, Lagrangian method. So you define mass, position, velocity, acceleration, pressure, temperature, etc. as a function of time. and this track the location of a migrating bird. Means what? Observer also have to move with that particular object. So this is going to be what? Langrangian method. And there will be separate equation for each particle motion. We have to study all the particles, and therefore the equations will become too much. In this case, what will be there? If you are writing the equations of flow parameters, maybe velocity, acceleration, so equations will be become too much. Too many more equations will be there, because every fluid particle we have to trace, observer also have to move. So equations will be definitely more, or we can say simply more equations are there, more equations, more mathematics involved, because more equations. So therefore more equations are involved in this particular Lagrangian method, and therefore this Lagrangian method is considered as cumbersome. Cumbersome means what? It is considered as cumbersome means it is going to be considered as complex, because too many equations are there, and we have to what? Cumbersome, we can say cumbersome or complex, because each and every fluid particle we have to write separate equations. Okay, observer also have to move with that particular fluid particle, and more equations will be generated, because fluid flow consisting of more number of fluid particles. So each fluid particle motion we have to observe, we have to write the equation, we have to trace the particle, and therefore now in the fluid flow equations will become more and more, and the method will become cumbersome and complex. Hence this method is not, this is accurate method, because we have to consider what? This is very accurate. As per that other method, Eulerian method is considered, it is accurate. But what happens is there, as many equations we have to create, we have to solve. Therefore, this equation is, this method is what? Cumbersome or complex. Accurate, but here lengthy method is there. Therefore, it is very lessly, or it is not max nowadays. The Lagrangian method we are not going to use, because cumbersome, complicated. Though it is accurate, but cumbersome and complications and lengthy method is there. So, for example, we are tracking the method, means we are also running with that particular bird, group of bird, or with the migrating bird. So then we have to move, and definitely equations will be complicated, and this method therefore not used frequently in the fluid mechanics study. Now next method is there. Next method also describes flow field, velocity, acceleration, pressure, temperature, etc. as a function of position and time. As a function of position and time. Now here what we have to do is there, observer have to remain stationary. What is that in this method is there? Observer, who is observing that equation, observer is there. So observer have to be stationary. So we have to here at one section, at one particular here space, where the observer have to be remain steady or static. Observer is not is fixed. Observer is fixed, or it is not moving. So it is okay at a one particular point, it is taking moving. Now count the birds passing a particular location. Now suppose we are sitting at one particular location, fixed location is fixed, and we are counting which are how many birds are there, how which bird is going fast, which bird is going with lesser velocity, slow. So with at one particular junction we have to see and we have to count. So generally we are considering a section. So at a section on this path, at this particular space section, how what is the velocity of that particular fluid particle? So therefore, as we are considering it as a section, so section consisting of number of particles. So therefore, only at a section we are observing. Therefore, equations will become very much less as compared to, because only we are at a particular location or at a section, and equation will definitely in that case equations are less, and as compared to Eulerian, Lagrangian method equations are less, and therefore it can be solved easily. Okay, simple equations we can write. Okay, general equation here, and these equations we can solve. So therefore this method is mathematically simple, not that much complicated or cumbersome. So not the simple method is there. Okay, but as in Langrangian method, we are taking care of each and every particle. Here we are taking care of only along the section all the properties, and therefore as accuracy if you consider in the two methods, so Langrangian is too much accurate than Eulerian. But here what we are saying that this method is very simple. It is involving less number of equations. It is, but results are little bit right nearby Lagrangian. So this is also considered as what accurate, but Lagrangian is more accurate. But as Lagrangian is very much complex, so and here in Eulerian method equations are less. Therefore, this is simple, and this method henceforth is used for the fluid flow analysis. So what which method? Eulerian method, because for the fluid flow analysis. Flow analysis henceforth which we are going to use which method? Here Eulerian. So we are all the flow properties etc. now in the fluid mechanics we are calculating with the help of this Eulerian method. We are not going to use the Lagrangian method because it is cumbersome and complex. Understood? If understood, give your message in chat box or unmute and tell. Please, so that we can move to further part. Yes, Nikita Power very active. Okay, good. Yes, others only Nikita is concentrating. Okay, good. So now everybody have to remember that henceforth we are going to use which method? Eulerian method. In which method? Observer is fixed. Many times in the examinations they are going to ask the MCQs also. So in Eulerian method, observer is dash fixed or moving or here none of these or both of these, like this. So in the Eulerian method, observer is fixed. Lagrangian method, observer is very also moving. Okay, not a location is not constant. So there we have to trace each and every particle. We have to trace the motion in Lagrangian. Here we have to observer have to be fixed, and at a one particular section we have to observe the fluid flow properties. For example, velocity, acceleration, pressure, etc. And in Lagrangian, all these properties can be traced, but we have to move and we have to write the equations for each and every particle. Here, only at a one particular section, we have to write the equations. So, as compared to Lagrangian, motion equations are very less in case of the Eulerian method, and hence this is going to be simple, and hence it is used here in the fluid mechanics frequently. Now, after this, we have to see which are the types of the flows. Which are the types of flows? Okay. So first of all, is there a steady? There are types of flows. So in our syllabus, one is steady flow, another is unsteady flow. Second is uniform flow, another is non-uniform flow. Third flow type is there laminar and turbulent flows. Fourth one compressible and incompressible flows. Then rotational and irrotational flows. And sixth category in that type of flow is one-dimensional flow, two-dimensional flow, and three-dimensional flow. Okay. So types of fluid flow are one is steady and unsteady flow. We have to see what is meant by steady and unsteady. Uniform and non-uniform flow. Laminar and turbulent flows. And our fourth one is compressible and incompressible flows. Next is rotational and irrotational flows. And then last category of types of flow in that case, one-dimensional, one, two, and three-dimensional flows. So generally what happens here in questions they are asking when now if offline examination will be there, they will ask explain the different types of fluid flow with examples. Okay. Now first flow we are going to consider is that here steady flow, the fluid in which the fluid characteristic, the fluid flow in which the fluid characteristics like velocity, pressure, density, etc. at a point do not change with time. Okay. So whatever the properties are, generally we are considering velocity only here in the fluid kinematics. So, or we can say velocity is not changes or remaining constant with respect to time. Okay. So here space is going to be constant, but at right, suppose that at where time we are taking one constraint. Now I think it is 11:30. Let us consider 11:30. So we are taking the velocity we are calculating at 11:30 at a fixed point. Okay, one fixed point we are considering as a section, and we are velocity calculating the velocity of fluid at 11:30. If after some time, after 10 minutes, at 11:45 also, if you are taking the reading of velocity, if these two readings are coming same, then we say that the flow is steady. The fluid flow in which the velocity of that particular fluid flow remains constant, or fluid characteristics like velocity, pressure, density at a point do not change with time, means they are remaining constant. So, or remaining constant, or remaining constant. Constant. Now, for example, let us mathematically we can say, let us consider that dou v. Now here it is, velocity is function of also space also. Therefore, dou v by dou t is equal to 0, or du dou rho by dou t is equal to, change is constant, change is equal to 0 with respect to time, means what? Velocity is equal to constant with respect to time. Okay, or density is equal to also constant with respect to time. Density is equal to constant. Or we say that pressure dou p by, at a one particular position, dou p by dou t is equal to constant, or pressure is equal to constant. So these types of flows are called as what? Steady flows. Now another type of flow is there, that is here unsteady flow. How we define unsteady flow now? In which the fluid velocity, pressure, or density at a point changes with respect to time. They are going to be changes with respect to time. So here example, now first of all example of steady flow is there. Let us consider one tank, and this tank, this water, we are storing the water. Okay, if this head, we can leave the height, or now we are not doing the height, if the height or this depth of water, we can let us consider h, height or depth of water in the tank. If it is constant, we are maintaining constant, and if you are taking a discharge, let us consider we are taking discharge, and here also through pipeline, if how much discharge we are taking, if this is some part is going to be added, that type of flow is called a what? Steady flow. Means what? This head, if you are remaining maintaining constant, जर आपण टाकीतली जर पाण्याची लेवल जर आपण सारखीच ठेवली, जेवढं पाणी घेतलं तेवढं पाणी त्यात लगेच किंवा सायमल्टेनियसली जर आपण वतत राहिलो वरून, आणि तेवढी लेवल जर आपण कॉन्स्टंट ठेवली टाकीतली, तर जे पाणी येणार, whatever the water is coming with which velocity, here this velocity will remaining constant with respect to time, and this kind of flow is the example of steady flow. Everybody getting? So level head. But if we vary the level, now suppose that we are not adding any kind of water in this tank, decreasing, this is decreasing. Okay, and if you are taking water from this, okay, one small bucket or glass, okay, and if we are taking continuously water, this level is goes on decreasing. In this case, the variable head, the head, yeah, the water coming from a tank having variable head is example of unsteady flow. What is unsteady flow? In which the fluid velocity, pressure, or density at a point changes with respect to time, or velocity is more, we say that velocity is not equal to constant, exactly opposite to the steady flow. Okay, so velocity is not remaining constant, or we say that dou v by dou t is mathematically, you can say, not equal to 0, or dou rho by dou t is also density, if you take, is also not equal to 0. This is called as what? Steady flow and unsteady flow. Everybody understood this steady flow and unsteady flow? Please ask doubt, or please write message in message box so that we can continue to next flow. Example also. Example is flow of water through a through a tank having variable head. Through a tank having variable head. And steady flow, the flow of water through a tank having constant head. Constant head of water means what? हेड म्हणजे जेवढं पाणी आपण घेतोय तेवढं पाणी जर तिथे वाढलं तर ही लेवल जी आहे हेड ला म्हणतो आपण हेड, दिस विल रिमेन कॉन्स्टंट. एव्हरीबडी अंडरस्टूड स्टेडी फ्लो अँड अनस्टेडी फ्लो? प्लीज राईट इन एस मेसेज बॉक्स. Pramod, good, very active Pramod now. Yes, yes, yes. Nikita Pawar, yes. Okay, Diksha, yes. Balaji Pise, yes. Okay. So next, let us now consider to next point. Then another type of flow is called as uniform flow. Uniform flow and non-uniform flow. Uniform flow in which now steady flow we can consider many properties: pressure, velocity, acceleration, etc. But uniform flow is related to only velocity. Uniform flow is only related to velocity. So what is that? Uniform flow in which the velocity of flow, uniform flow means what? In which the velocity at a given time does not change with respect to space or length of direction of flow. That type of flow is called as what? So time is constant here. And suppose that at 11:30 we will take reading at different places. Suppose that this is one pipe is there of same diameter pipe everywhere. Uniform diameter pipe is there. And let us consider this water is there. And let us take at this one, this is one section. This will be section 1, 1. So this will be section, let us consider 2, 2. And this will be section 3, 3. Okay, so at a one section, also this is your velocity is there, v, okay, v1 is here, v2. So at a one particular point, let us consider at now here at now 11:40 time is there, okay, 11:44. So 11:44, if you take the readings of three velocities, okay, so at all sections velocity should, if it is remaining same, then we say that the flow is going to be uniform flow. Flow is going to be what? Uniform flow. Okay, so if the velocity of flow is remaining constant throughout all sections to the in the direction of flow, then we say that the velocity, the flow is going to be constant or uniform flow. So at same time, here what is that same juncture is that at same time we have to record all the velocities at section 1, 1, 2, 2. So v1 is equal to v2 is equal to v2. So if the velocity at a given time is what? Same time, given time does not change with respect to space. So that type of flow is called as uniform flow. So here it is that here with respect to space, or we can say that here dou v by dou x with respect to position. Okay. Or we say that here constant is what? Time is equal to constant. So at same t is equal to constant. Is equal to 0, and that is called as steady uniform flow. Okay, dou v by dou x at t is equal to constant is equal to 0, or dou u by dou x at t is equal to constant is equal to 0. This is also called as what? Uniform flow. So Example is that the flow of water in uniform diameter pipe. म्हणजे एका सारख्या डायमीटरच्या पाईप मधून जर पाणी जर वाहत असेल तर it can be said as uniform flow. Non-uniform flow, if the diameter is varying, as a area बदल diameter, if we change the diameter, definitely velocity will also not remaining. इथे वेगळी असणार, इथे वेगळी असणार, इथे वेगळी असणार. म्हणजे पाईपचा डायमीटर जर आपण चेंज केला, velocity v1 will not be equal to v2. And in that case, in which the velocity at time any time changes with respect to space. म्हणजे आता आपण 10:45 जर रीडिंग घेतलं तर इथली velocity समजा v1 येईल. v1, this will be v1, let us consider. At section 2 velocity will be v2 and section 3 velocity will be v3. Okay, so at same given instant of time, at given time, if it is changes with respect to space, then that type of flow is called as what? Non-uniform flow. So velocity is not remaining constant. Here it is called as what? Or dv is not equal to 0. So there is change. Okay, so that type of flow is called as uniform flow. For example, dou v by dou x, velocity v along x-axis. Okay, at same time interval, t is equal to constant. If is not coming equal to 0, that type of flow is called as non-uniform type of flow. So what is example here? Water flowing through non-uniform diameter pipe. That is an example of non-uniform flow. Understood? Any doubt? Uniform flow, non-uniform flow? Any doubt?
No, sir.
Okay, thank you. Any other? Only Prathamesh is giving answer. Others, please. Pramod Avlekar. Okay. Diksha Admile. Okay. Shivani Nene. Good. Good. Now, another type of flow is there. It is called as what? Laminar flow and turbulent flow. Now, laminar flow is what? Generally, if you consider the fluid flow motion, the fluid flow is happening like that. One layer of fluid is lying over the another layer, or laying that one layer of fluid is laying on another layer. So this is, if we consider this layer, this will be another layer. This will be third layer of fluid flow. Now, if these layers of the fluid particle, if they are moving with, or these layers are moving parallel with each other and straight, they are moving straight and parallel with each other with some well-defined path, well-defined manner. So that type of flow is called what? Laminar flow. What is that? Fluid part. Now here if you see, here we can see that here this is one layer. Okay, so this another layer is moving parallel. Okay, another in between also layers are there. These layers are moving parallel to each other. So that type of flow is called as what? These layers are not get mixed with each other. So these layers are called as what? This type of flow is called as turbulent flow. If it is mixed, layers are mixed, if one layer in another layer, that is called as turbulent flow. And if the fluid particles are moving in such a way that these layers are moving parallel to each other, straight, well-defined path, so this is called as laminar flow. And the laminar flow, to identify that whether the flow is laminar or turbulent, there is one number in fluid mechanics that is called as a Reynolds number. It is called as what? Reynolds number. And if this Reynolds number, the formula of Reynolds number is what? Rho Vd divided by mu. So this is what formula? Reynolds number, rho Vd divided by mu. And if this Reynolds number is less than, if it is less than 2000, then that type of flow is called as what? Laminar flow. Mathematically, if you or graphically we say the fluid particles, they are moving in the form of layers. and these layers are straight, well defined, parallel to each other. That type of flow is called as laminar flow. As these layers velocity only rho density is not changing, constant. Diameter of pipe is also changing, not changing. Dynamic viscosity is the internal property, internal resistance. It will not change. So Reynolds number only depends on velocity. And to have the less Reynolds number, okay, below 2000, we should have the velocity also more. So for laminar flow, less velocity of flow is very less. So velocity is less. So that type of flow is called as what? Laminar flow. Velocity is less. Okay. So in which the fluid particles move along the well-defined path and straight lines or streamlines. Okay, straight lines. Okay. So that type of flow is called as here laminar flow. And for laminar flow, Reynolds number is one of the number is there. Now afterwards we will define Reynolds number. So this Reynolds number is less than 2000, and laminar flow occurs at very low velocity. The next type of flow is what? The fluid particles. Okay, fluid particles, if they are mixed with each other, I told all earlier that if they are mixed with each other, maybe sea motion, dabdaba, mota, okay, or this is going to be what? If the fluid layers are mixed with each other, or they are moving in the zigzag form like this, okay. So instead of moving straight, if one layer is mixed with another zigzag flow. So these type of flows are called as turbulent flow, in which the fluid particle does mix with each other. Okay, layers are mixed with each other. So efficient mixing. Okay, velocity at point may fluctuate and is high. Velocity is also what? Very high. And I, as this is going to be very high velocity is there. So here Reynolds number again I will define as one number. Reynolds number, it is equal to what? Rho Vd divided by mu. And if this Reynolds number, this is going to be specifically we want to calculate Reynolds number. So if it is greater than 4000, Reynolds number is greater than 4000. What is the formula of Reynolds number? Rho Vt divided by mu. Okay. And if this Reynolds number is greater than 4000, so definitely in that case, that flow is called as what? Turbulent type of flow. Okay. So this occurs at very high velocity. Now, if we in general, if they will ask the question that what will be the flow of river? What will be the flow of river? Whether it is laminar flow or turbulent flow? Who will give answer? Anybody of you? What is the flow of river? Anybody? Either laminar or turbulent. You don't maybe answer me wrong.
Turbulent.
Turbulent. Okay. Anybody other than okay. Now answer should be like that. The flow will depends on velocity. So if the river is flowing with very low velocity, if water is not released from डॅम म्हणजे धरणातून जर पाणी सोडलं नाही आणि तेच पाणी जर आपल्याला संत वाहत असेल एखादी नदी, तर दॅट टाइप द फ्लो इज व्हॉट? लॅमिनार, बिकॉज it is moving with very constantly. One layer is flowing with another layer. No fluid particles of one layer is mixed with another layer. So that time the velocity of river will be the flow of river will be laminar. But if the velocity, if water is released from dam, or if another stream is mixed with that particular water with very high velocity, okay, so in that case the water is flowing with very high velocity like the waterfall, etc. Okay, and the fluid flow, these layers will mix with each other. So their velocity, there will be turbulent flow. So this is depends on the velocity. If velocity is too much and if layers are mixing with each other, therefore flow will be turbulent. Understood? Laminar flow and turbulent flow. Everybody? If it's yes, write down message box. Okay. For MCQ, they are going to ask for laminar flow, what is Reynolds number? And for turbulent flow, what is Reynolds number? They are going to ask. So Reynolds, I want in chat box, Reynolds number for laminar flow is, you can write down your number. and Reynolds number for turbulent flow. Write down RE. RE means Reynolds number. Write in chat box. Chat box, I want to answer. Reynolds number. Nobody. Reynolds number for laminar flow is less than 2000. Okay. RE is less than 2000. Good. Less than 2000. Okay. Right. Everybody have to remember. Reynolds number is and turbulent flow greater than 4000. Okay. Very good. Promote. Okay. 3-4 students given answer. No problem. But concentrate. Now, another type of flow is there that if the density of fluid changes from point to point, then that type of flow is called as what? Compressible flow. For example, flow of gases. So here, if rho is not equal to constant, okay, or d rho of dt is not equal to 0. So that type of flow where density is variable. If we apply pressure on a fluid, its velocity volume is goes on changing. That type of flows are called as compressible flow. For example, gases. If we compress the gas, if you apply pressure on the gas, its volume is goes on changing. So that type of flow is called as compressible flow. Rho is also flow of gases, flow of steam, okay, in the pipeline. So this will be considered as compressible flow. As more pressure is applied, volume will be less. So pressure after applying pressure, volume changes, and volume changes means density changes because density is equal to everybody know mass is remaining constant of flow. If volume is changing, density will also change because rho is equal to mass upon volume. Okay, so therefore if density is changing, volume is changing, therefore density will also change because mass of fluid will remain constant. So density is not constant for the fluid flow. That types of flows are called as compressible flow. And incompressible definitely in which the density of fluid flow remains constant. Hmm? Incompressible in which density of fluid flow not changes. Here it is what? Fluid flow not changes. Not what is missing. Not changes from point to point is called as incompressible flow. So for example, water is incompressible flow because if you apply more pressure on water, its volume will not change. It may occupy more head, but volume will remain same. Or as volume is remaining same, density will also remaining same. So density of fluid is remaining constant. So that type of flow is called as here incompressible flow. For example, flow of water in any pipe, and compressible flow of gases or steam in the pipe. Now, another type of flow is called as what? Rotational flow. Now, rotational flow means what? In which the fluid particle while flowing along straight line or streamlines also rotate about their own axis. So that type of flow is called as what? Rotational flow. म्हणजे फ्लुइड पार्टिकल पुढेही जातात आणि जाताना एकमेकाभोवती सतत काय करतात, दे आर ऑल्सो गोइंग टू बी रोटेट along their own mass center, own axis. So that type of flow is called as what? Rotational flow. Okay. So for example, if we have to move the fluid particle, so this is going to be like this. So like this kind of flow is called as what? Rotational flow. For example, anybody rotational. So one is what? Earth is taking one complete round around sun. It takes how many days? 365 days. That we call it as year. But every day, at when it is moving, Earth is taking one round around itself. Okay, in 24 hours, and then that is called as what? Here rotation means while taking more round on around sun. So Earth is taking one it's around its along itself. So that is called as what? Rotational flow. Okay. For example, whirlpool in a water. Whirlpool म्हणजे बहोरा. पाण्यामधला जे बहोरा असतो, पाण्यामध्ये बहोरा म्हणतो आपण. Whirlpool in a water. त्याचं नाव काय? whirlpool in water. So fridge company माहिती whirlpool. It is what? Whirlpool. Whirlpool in water is nothing but what? Here example of rotational flow or water flowing through along the basin. आपण जर बेसिन मध्ये जर हात धुतला तर काय होते, बेसिन जर सर्क्युलर आहे तर वॉटर इज गोइंग टू बी वॉट सर्क्युलर फिरत असताना स्वतःभोवती फिरत 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 खाली ड्रेन होलला जातं. त्या फ्लोला काय म्हणायचं? रोटेशन. म्हणजे बेसिन मधला फ्लो जो आहे तो रोटेशनल आणि ड्रेनच्या नंतरचा फ्लो आहे, ड्रेन होलच्या नंतरचा फ्लो आहे तो काय? इरोटेशनल. इरोटेशन म्हणजे काय? इन विच द फ्लुइड पार्टिकल व्हाईल फ्लोईंग along streamlines do not rotate about their own mass center. So this is called as irrotational flow. म्हणजे जनरल फ्लो, द फ्लो ऑफ वॉटर इन अ पाईप, तिथं काय डायरेक्ट आपण हे केलं तर ते दे आर नॉट गोइंग टू बी रोटेड along their own mass center, along their own axis. So that is called as irrotational flow. म्हणजे बेसिन मधला जो फ्लो आहे आतला नळापासला बेसिन मधला ड्रेन होल पर्यंत, ड्रेन होईपर्यंतचा, दॅट इज कॉल्ड एज व्हॉट? रोटेशनल फ्लो. आणि आफ्टर ड्रेन होल, at the drain hole here, the flow will become now afterwards irrotational. Irrotation means what? While flowing, fluid particle does not rotate about their own axis or own mass center. So that type of flow is called as irrotational flow. Okay, now everybody understand these types of flows? I have covered all the types of flows, and where now in this lecture we have covered two methods of fluid flow description. Everybody understood? Understood? Please write message in your message box. Yes, sir. So again in afternoon lecture also we'll revise it and we'll go. Okay. Thank you then. So now I think you can leave. I will take attendance from Traunke sir or and you write your attendance in chat box. So